let's take a look at an example of combined variation. So this is example number 7. And it says the following: write a mathematical model that represents the following. So we're going to start over here. Z varies directly as x and the cube of y and inversely to t. Okay, and then down here it says when z equals -3, x equals 0.25, y equals 2, and t is equal to 4. So the first thing we're going to do is we're going to write an equation that represents this. And anytime I see direct variation, I'm going to think to myself, these are going to go in the numerator. And anytime I see inverse variation, I'm going to think to myself, that's heading into the denominator. So the initial equation, z varies directly as x and the cube of y. And don't forget our constant proportionality. And inversely to t, so that means we're going to throw them all over t. Now we're asking here, the question's asking for a mathematical model. So remember, when we're asking for a mathematical model, what that means is we need to find that number for k, the numerical value for k, and then substitute it back in. Well, here's what I'm going to do. I know what z is. Z is -3. I know what x is 0.25. I know what y is 2. I know that t is 4. I'm going to substitute these values in and help us find k. So substituting in, I have -3 is equal to 0.25 times 2 cubed times k all over 4. Okay, so let's start simplifying in the numerator. We have -3 is equal to, so we're going to call this, let's see, 0.25 times 8 times k divided by 4. So that's equivalent to saying -3 is equal to, so we multiply 0.25 times 8 and then divide that by 4. We get 0.5 times k. And then to get k by itself, I'm going to divide each side of the equation by 0.5. And then I'm going to my calculator, -3 divided by 0.5. That's the same thing as saying -6. So k is equal to -6. Again, remember the mathematical model is when we rewrite the equation substituting back in for k. So for the mathematical model, I get z is equal to x times y cubed times -6 all over t. This is my mathematical model. So this is answering the question that we were just asking.